Given question, find the magnitude and direction of reactions at supports A and B in the beam AB as shown in the diagram.
Let us understand given question with the help of diagram. If we observe the beam AB, then it is hinged at point A. That means beam AB is free to rotate about the point A. So reaction can be in any direction. So we will consider the horizontal component and vertical component of the reaction at point A. And when we find the value of horizontal component as well as vertical component, then we can find out the resultant of these two components, that is the reaction at point A as well as its exact location at point A. Now if we move to the end B, then end B is having roller support and this roller rests on the inclined surface. If we observe the given diagram, then this inclined surface is making an angle of 60 degree with vertical line. So we have to show the reaction which is perpendicular to this inclined surface at point B, and we will find out this reaction at point B. Now we will first draw the free body diagram and we will consider the equilibrium of the system to find out reaction at point A and reaction at point B. We will first show the horizontal component and vertical component at point A. I will show here horizontal component as HA and vertical component VA. So this is the end A. Now first force, that is the point load, is given 59 Newton and which rests at 60 degree to the horizontal. So we will resolve this load into two components, horizontal component and vertical component. So here is the angle 60 degree. Now horizontal component is nearby to angle 60 degree, so its value is 59 cos 60, and vertical component its value is 59 sin 60. Now in the same way there is the second point load 80 Newton. Now again we will resolve this into two components, vertical component and horizontal component. Now its angle is also given 75 degree with horizontal. So for horizontal component 80 cos of 75 and for vertical component 80 sin of 75. Now we will move to the next 49 Newton. So it is also inclined at an angle of 60 degree. So for this 60 degree we have to show horizontal component and vertical component. So horizontal component is nearby to angle 60 degree, so its value is 49 cos of 60, and for vertical component 49 sin of 60. So I will write here it is 49 cos of 60. Now we will move to the end B. So this is the end B. Now at end B we have to show reaction which is in perpendicular to the inclined surface. So first I will show reaction at this point because we have to draw perpendicular. So I will draw here one perpendicular line to the inclined surface. And this reaction at point B is known as RB. Now we have to split this RB into two components, horizontal and vertical component. Because if we observe, this is the inclined line. So I will split this horizontal and vertical component. Now how to find out its value? So if we observe this inclined line making an angle 60 degree with horizontal. Now this RB is perpendicular to this inclined line. And for this vertical line, this horizontal line is perpendicular to the vertical line. So if these two lines making an angle 60 degree, then these two perpendicular line also making the same angle at the point of contact. So this is the point of contact and here is 60 degree angle. So how we can show this? So we have to show this horizontal component RB cos of 60 and this vertical component RB sin of 60. Now we will show here. So this is the inclined line. This is known as RB. Then here is the horizontal component and here is vertical component. So RB cos of 60, RB sin of 60, and here is the angle 60 degree. Now we will consider equilibrium of this system. So when we consider equilibrium of system, then we can show the summation of moment of all forces about any point, or we can say about moment center, is equal to 0. Summation of all vertical forces is equal to 0 and summation of all horizontal forces is equal to 0. So we will first take the moment of all the forces about point A is equal to 0. Now why we are going to take the moment center as a point A? If we observe this free body diagram, then here HA and VA, these are two unknown component of the force, and here RB, that is, this is the one unknown component. So if we take moment of all the forces about point A is equal to 0, then this HA and VA acts at point A, so these two components will become 0, and then only one unknown is remaining, that is RB, and we can find out the value of RB. So when we take moment of all the forces is equal to 0, then first we will take this 59 Newton force. Now if we observe, here is the horizontal component. Now if we extend the line of action of this horizontal component, then it is passing through A. So there is no any perpendicular distance, that is perpendicular distance will become 0, and so we are not going to consider this 59 cos 60. Now we will move to the vertical component. Now if we observe the vertical component, then 59 sin 60 is there and perpendicular distance is 1 meter. So that is mentioned in the question. Now if I move the compass about point A in the direction of this force, then it is in clockwise direction. So we have to take positive sign. So how we can write this? Plus 59 sin 60 multiplied by 1. Now we will move to the next 80. Now horizontal component passing through point A, so we are not going to consider this. Now 80 sin 75. So if I move the compass about point A in the direction of this vertical force, then it is also in clockwise direction, so we will use positive sign. So plus 80 sin 75 multiplied by perpendicular distance. So if we observe perpendicular distance from point A is 1 plus 2, that is 3. Now we will move next 49 sin 60. Now this horizontal component we are not going to consider. So again it is in the same direction, that is in clockwise direction. So take positive sign. So plus 49 sin 60 multiplied by perpendicular distance. So 2 plus 1 plus 2.5, that is equal to 5.5. Now we will move to the next RB. Now if we observe this horizontal component, because point B is here, this horizontal component is also passing through point A. So here we are not going to consider this, we are going to consider RB sin of 60. Now if I move the compass in about point A in the direction of RB, then here is the direction, and this direction is anti-clockwise, so we have to use negative sign. So minus RB sin 60 multiplied by perpendicular distance. So from this end B, distance is given, that is A to B distance is given 6 meter. So we have to multiply with 6 is equal to 0. Now when we solve, only one unknown term RB, and RB is equal to 100 Newton. Now we will move to the next. Summation of all horizontal forces is equal to 0. Now if we observe, RB is known, so we can calculate RB cos of 60, and only one unknown term is HA, and we can find out the value of HA. So how to write this? HA is towards right hand side, so take positive sign. HA plus 59 cos 60 minus 80 cos 75, 80 cos 75 because direction is towards left hand side, plus 49 cos of 60 minus RB cos of 60. So if we solve this, then we will get HA 15.9 Newton. Now in the same way we will calculate VA. So here the sign is important. So when the horizontal component is having the direction towards right hand side, use positive sign, and for the direction towards left hand side, use negative sign. Now in the same way, for summation of all vertical forces, for the upward direction use positive sign and downward direction use negative sign. Here is VA minus 59 sin 60, then minus 80 sin 75, minus 49 sin 60, and here RB sin 60 is having upward, so plus RB sin 60 is equal to 0. So one unknown term is VA, so VA is 85.5 Newton. Now when we solve this HA and VA, then we can calculate its a resultant R. That is the magnitude of resultant R, that is under root of HA square plus VA square, and which is equal to 87 Newton. Now this is about the magnitude. Now what about the direction? Now if we observe HA is having positive magnitude. So what is its a direction? So for positive value, direction is towards right hand side. VA is also having positive magnitude, and for positive sign, direction is in the upward direction. Now we will draw here one rough diagram. So for HA and VA, so we will show here, this is the horizontal component and this is the vertical component. So we have to take one care, that is these two points should meet at a single point, that is these two arrows should meet at a single point. So this is HA and this is VA. Now I will show here one rough construction. I will complete this, and if I draw, it's a resultant. So resultant of HA and VA we will show in this way. So this is the RA. Now how to find out the exact location of RA? So for that we have to find out angle alpha. So angle alpha we will consider RA is making an angle alpha with HA. Now if we observe this diagram, suppose I will say this is point A, this is point B, and this is point C. So these two angles are opposite angles. So here is also angle alpha. Now from the triangle ABC, if we write tan of alpha, so what is the value of tan alpha? That is opposite side by nearby side. Now this opposite side is BC, and BC is nothing but VA divided by nearby side is AB, and AB is equal in magnitude with HA, VA by HA. So alpha is equal to tan inverse of VA 85.5 divided by HA 15.9, and therefore we can find out the value of angle alpha, and when we get the angle alpha, then we can locate the exact location of RA. We get the value of alpha is equal to 79 degree. So it is the angle between horizontal component and RA. So how to show this resultant RA? So we have to take here one angle 79 degree, and here is RA. So we have to show this RA and this angle is 79 degree.